Assalamualaikum warahmatullahi wabarakatuh. My name is Hadi Hakim Roslan. So for this presentation, me and my group will be presenting about our group project, which is high technology export. My group made up consists of Abdi Hamid, Akmal, and last but not least Solihin, to which all of us will present our own part in this video. So first of all, to begin our video, the objectives of researching these factors affecting high technology export is because high technology export is one of the main key for sustained long-term economic growth. This basically means that these export sectors can help improve the economic environment by enlarging or enhancing the productivity of the business involved within these sectors. Not only that, it can also help increase the competitiveness either in terms of national level or even within the country itself, which correlated with the previous point, which is increased productivity. So, what is the relationship according to the theory of explanatory variables? To start with, we expect a positive relationship between FDI and HDE because as FDI increase, there will be more foreign capital and even technologies expertise to help the countries to increase production and export their own high technologies. Next, we expect positive relationship between patent and high technology export as it is anticipated to increase as the number of patent application from residents for new invention rises, especially when a successful innovation is patent and given the exclusive right to produce and export the goods or system. So next, we have it is expected that the relationship between human capital in terms of education and HDE will be positive because a country with high human capital index has more capacity to generate and utilize high technology while exporting it to other countries. Next, we also expect a positive relationship between R&D and HDE as more R&D can lead to innovation, which can help create new products and help the country become more competitive in the global marketplace and produce high technology export. Furthermore, we expect positive relationship between trade openness and HDE because as the countries are more open to export and imports, it can access larger market that consisted of international market, which can help them export more of their technologies. Last but not least, we expect a negative relationship between developed countries and HDE. As developing countries are more expected to export more high technologies, four of their significant progress in building new and unique technologies while offering new market opportunities compared to already developed countries. Moving on to the data used for our research, these studies use cross-sectional macro data which consists of 76 countries or observation in 2015. Not only that, the model data is obtained using secondary data which is taken from trustable and other sources such as Data World Bank, WIPO, Our World in Data, World Economic Forum, and last but not least, WEBs, to which all of them are taken during 2015. Aside from that, our dependent variable has been indicated as percentage of high technology export in manufactured export in 2015. Furthermore, for our explanatory variables, FDI has been calculated as net inflows of FDI as the percentage of the GDP in 2015. For patents, it is indicated as the proportion of residents' application for patent per million population for 2015. For R&D, it is calculated as percentage of GDP in terms of government expenditure for R&D for 2015. For human capital, it is indicated as percentage of human capital for education, health and longevity using human capital index for the year 2015. Next, for trade openness, it has been indicated as percentage of countries' total trade, export plus imports to GDP in 2015. Lastly, for developed countries, we have assigned the number 1 for developed countries and 0 for developing countries for the year 2015. Next, for our model, we have generated a linear form model as has been shown in the slide. So as for our initial expectation, we expect that the coefficient for beta 1, beta 2, beta 3, beta 4, and beta 5 are positive, while beta 6 is expected to negatively affect the dependent variables. As for that, after constructing the regression equation model and running it inside the eViews, we managed to get the prior result, which are beta 1 equals to 0.010, beta 2 0.327, beta 3 equals to negative 0.001, beta 4 equals to 5.951, beta 5 equals to 0.025, and lastly, beta 6 equals to negative 6.779.
Then we move on to the first diagnostic test, which is Ramsey reset test, to see whether our model had included all important variables and correctly specified to avoid for specification error in our model. This test is conducted to support the theoretical justification for the specification of the model. Then to test for Ramsey reset test, there are two fitted variables added to this model, and we want this to be 0, with the level of significance of 0.05, the F statistics is 1.2893, P value is 0.2822, and critical value 3.15. Thus, we accept the hash knot, which means that there is no specification error. Check whether there is a perfectly linear relationship between explanatory variables to avoid the problems of perfect multicollinearity in this model. Then we regress each of the explanatory variables to other explanatory variables. Thus, the result shows that the value of R squared for FDI, human capital, and patent is below 0.8, meaning that there is no problem of perfect multicollinearity. After that, for R&Ds, even though the value of R squared is 0.788, where there is an imperfect multicollinearity, but it is still acceptable as it is below 0.8. And lastly, there is no perfect multicollinearity for trade openness and developed country as it is 0.3 and 0.58.
Now we will run a serial correlation test to see whether the error terms in the models are correlated to each other or not. Since we have no impure serial correlation, therefore we are concerned to test the impure serial correlation only. Pure correlation has many orders, so we are going to use Durbin-Watson d-test to test the first order correlation, and we will use Bruce-Godfrey LM test to test second order correlation. For Durbin-Watson d-test, we want to test whether there is first order correlation or not. Therefore, our H null is rho equal to 0 and H alternative is rho not equal to 0. We set our level of significance to 0.05. The d value for the test statistic is 1.8388. The critical value are dl equals to 1.313, du is 1.649, 4 minus du is 2.351, and 4 minus dl is 2.687. Since the d value is 1.8388 is in between the critical value du and 4 minus du, which is in between 1.649 and 2.351. Thus we accept the H null. Therefore, there is no first order correlation for our model. Now we run the Bruce-Godfrey LM test. Based on the equation that we regress on the residual values, we set H null to be mu7 and mu8 equal to 0, and H alternative is mu7 and mu8 not both equal to 0. Our level of significance is 0.05, and the test statistic for EViews is the test statistic from EViews is f value equal to 0.108325. The critical value is 3.1504. Because of the statistic is smaller than critical value, thus we accept the H null. Therefore, there is no serial correlation for this model. We use wet test to test the heteroscedasticity in this model. Based on this test, we found that the critical value is greater than test statistic. Thus, we accept the H null, which means that the errors are homoscedasticity.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdi Hamid, and so here we have done the test for individual significance. We can reject the null hypothesis. Our level of significance is 0.05, which means that we accept a 5% probability of making an error of rejecting the null hypothesis when it is true or correct. So let's dive into our test. For foreign direct investment, we accept the null hypothesis, and therefore foreign direct investment does not significantly affect the high technology exporters. Next is patent. We accept again the null hypothesis, which means that patent does not have significant effect on high technology exporters. Moving on to human capital, we rejected the null hypothesis, and thus human capital has a significant effect on high tech exporters. Now, research and diplomacy, we reject the null hypothesis again, which means that research and diplomacy significantly affects high technology exporters. Next variable is trade openness. We accept the null hypothesis, which means that trade openness does not have significant effect on high technology exporters. The last variable is diplomacy. We accept the null hypothesis, and thus it doesn't have significant effect on high technology exporters. Moving forward to the overall significance test, the results show that the value of test statistic of f is bigger than critical value. Then we decide to reject the null hypothesis. Therefore, there is an overall significance. At least one of the experimental variables explain the high technology export dependency variable. We conclude that our 6 experimental variables jointly have a significant effect on our dependency variable. To put simply, there is an overall significance in our model.